Hello, good day. I'm sure you enjoyed that little break. Let's get into the IDE to check on those fault errors. So I just opened the STM Cube IDE by going in there. I'm going to create a new project to show you today about the fault errors. A new STM32 project. It's initializing to connect the target. I'll show my hardware. I connected and it's powered on. As you can see, it's powered on. Yeah, so here let's go to board selector, try to type nucleo f dash f411re, and that's the one. Select that, click next, and give a project name Day13 fault handling and analysis. And I'm going to show you from scratch, so let's open a target project type as empty and then click finish. So as you can see, it created the Day13 pay projects. I'll close all the other unwanted files so I won't get confused with you. Okay, because we're going to see the output at the console window here, you got to type a small piece of code that you can send character via printf statement. So as you would remember, going to example day2 on syscall, so that's that file. So you got to copy this from line 33 to line 48. So copy that, come to your project Day13, click on main, sorry, not main, click on system call, and just here type that, right click, paste, then come down. You need to copy the function name to send character, so copy that. Need to go to int underscore right and make this as a comment, pass the call the new function and pass the same pointer variable. Yeah, so you're done, you changed that. So go to main. I'll close all the system calls so you won't get confused. So close all the system calls. As you know, this is the reference or whatever in slash star and star slash. This is all the for everyone to understand what is this file for, file name, and who has written this file, and the license messages there. So if you want, you can keep it or you can just erase it. So I'll remove everything that's inside the program and start to compile. So we'll generate the .elf file. Okay, so right click, I'm going to build the project. This will generate the .elf file. Okay, it's happy, it's generated. So now let's go right click and debug as. Make sure you have the debug configuration. So go to debug configurations and you need to choose Day13. The new project is fault handling, so make sure you are on that. So right click, debug as, debug configurations. So we are on .elf. Okay, go to debugger, make sure the st-link, not now, st-link underscore, and also enable the serial wire weaver, and then click apply debug. So this will set the board with the debug options. I'll show you the board view. So that's a board view and it's connected, and as you can see the other light flashes, so that means it's connected. Yeah, okay. So now let's go and first enable the program. So going there, first you have to enable the fault. Enable the fault. So uint 32 underscore t space at asterisk and click on special function registers by going Windows, show view, go to special function registers, and special function registers will come. As you know, we are talking about two different registers. There are some registers that belong to Cortex M4, and there are some peripheral registers that from the third party vendor, that is STM32F411. So being we are in the control, you have to go to Cortex M4 on control, and this is where the file we are learning about SHC SR, the status hard control status register that you learned from your this one, system handler and control state register, SHCSR. So you need to copy that address, and as you can see, this has all the faults: usage fault, bus fault, mem fault. And the CFSR is for configurable fault status register, HFSR is for hard fault status register. So these three are important. So now we are enabling it, and we're going to copy this main SHCR. So send that into a pointer, created the pointer SHCSR equals then typecast uint 32 underscore t, and just copy this address, Control C, Control V, and just leave it like that. You don't need this, it's just enabling the register. PHCR syntax error F2 to focus. uint 32 underscore t, uint 32 underscore t, uint PSHCCR, uint 32t, uint 32t. Okay, and just say and build the project again. Okay, this will throw error because we haven't closed the project as UN32. Sorry. Say right click, build project. Warning is okay. We are worried about the error, so if it's error free, then that's okay, because we got to use this down below, so that's why it's throwing the error. So now we can create and enable the three fault handlers. So enable the fault handlers. So to do that, you got to have this pointer and enable the 3 bits that you learned from the presentation. So to do that, you just R-ing with that particular bit. So I'm R-ing the usage fault first. This is the usage fault, and this bit comes from the presentation here. Bit 18, that's usage fault. Bit 17 is bus fault. Bit 16 is mem fault. So that's what I'm enabling, those 3 registers in here. So I'll just copy the same, Control C, enter, Control V, Control V. Bit 17 is for bus fault. Bus fault, and bit 16 is for mem manage fault. Mem manage fault. Okay, so that's that. Mem manage fault. Okay, so now right click and build again. Build. Good. So right click on the project. Right click on the project. You have to connect the debug. To use the debug, you need to connect your board to your computer, otherwise you'll get error. So as you can see, the board is connected, and you can see it's powered on. So you have to connect, otherwise you'll get some error. So I'm going to go right click, debug as, make sure the configuration is set to .elf file, and the debugger ST-Link enabled, serial wire viewer enabled, close. So directly choose board STM32C application, and this will connect, move from switch from C++ perspective to the debug perspective. And once we are in, I'll run step by step, so you will see the register gets enabled here. So we are in SFR. As you can see now, the bits are 0 cross 0, 0 cross 0, so nothing has done. So I'll go step by step. So as you can see, every step it will enable that address, that bit. So now the usage fault is enabled, 0 cross 1. The next step will be the bus fault is enabled, and the next step will be the mem manage fault is enabled. So this is how you set and enable and verify in the registers that you enabled, and go step into function, and it's working. So now let's force into do some error messages. So let's force the processor, the processor to execute undefined instructions. So I'm just creating just a random program, just a random function to introduce the errors. So random address equals void pointer into the address, the random address. So I'm just starting with 0 cross 000 000, then 0008, and then random address of void random address of void control X void. Okay, then random address of. Okay, so now we just introduced a error which will give this problems with the function call. Okay, so now there is an option called terminate and relaunch. You just go and save the program and then go terminate and relaunch. This will include the yes, ST-Link. This will include the newly introduced problem, and it will throw the next step into the next step. So right click, debug as STM32 application, proceed with the launch implicit declaration, random address, sorry, spelling mistake. Random address. So right click, build the project, random address undeclared first, void random address of random address. Oh, okay, sorry, we got to copy the handlers first, otherwise it's giving a random address is declared, but we are not using it anywhere, so we got to write what exception that is. Okay, just checking my program, just one sec. Random address of void, yes. So we call this with the function exceptions, and random address equals that void of that address, and random address of this should clear the error. Let's see, build project. Yeah, it's cleared that. Sorry, I have written the function and I didn't do the exclamation at the end, so that's the problem. So now it's error free. Right click, debug as, and then make sure the debug configuration is set again. Yeah, .elf file, and the debugger ST-Link is enabled and the serial wire is enabled. So just save and then go right click and debug as STM32. So this will take to the debug perspective, and we can see the force error that we just introduced. It's still connecting, waiting for debugger connection. Yeah, then click on switch, as you can see, the three in if you just hit run, you will see the 3 bits are enabled. And once we introduce the usage fault and other things, and now because we just introduced the force with some random address, so and that is considered as a usage fault because the user introduced that fault and it's trying to access some address and saying that address is not available or not acceptable. So as you can see, the usage fault is enabled here. So 0x01, it's enabled. And also if we go into the configurable status register, and the invalid state here will be enabled because the user generated that and forced into showing some error. So that's why CFSR will have the invalid state as 1. Okay, so we can also start to see the error in here. So go here, click on data console and start to trace and set the port 0 here, enable. This is must enable that. Click OK and then start to trace and then go and hit run. At this stage we haven't included any error messages, so that's why the fault it's not replicating here. We haven't written the exception, it's just a forced error, so that's why it's there. So I'll terminate again and relaunch, and then we'll write the exceptions for these 3 faults that we just introduced. Okay, switch. As you can see, the default error came up and now it's sitting on the enable the fault error on DFSR. So if you go there, the DFSR error. Okay, so at this stage we haven't written the exception, so stop this and go to the system startup file and copy the handlers. So go to startup, go here, and it will be in the vector, so we need these 4. So copy that and come to your main program, and you got to write the exceptions now. It's in Word, you have to start that as everything as a separate function. Void handler of. So this is where we're going to see the output in the console window. So to do that, we are writing a printf statement, the exception, and this is hard fault \n. So likewise you have to create all the function for memmanage as well. So I'll do the memmanage now. Void memmanage handler of void. So you copy the same and just change the names. Control C, come here, paste, and change this to memmanage fault. Memmanage fault, and that's hard fault. So likewise change the bus fault as well. So void bus fault of void, and then copy the same printf statement. Control C, go in there, Control V, change that to bus fault, and the last one is the usage fault. So go and create this as a function. Then use the same and change it to usage fault. Come here, Control V and usage fault. Okay, so save that project. Now build again. It will throw some warnings. Ignore all the warnings. If it is error free, then that's all well and good. Now we can go and check every error. So right click, debug as, go to STM32. So 0 errors and 0 warnings. So we are in the debugger mode, and now we can check what fault it's showing now. So switch. Now we are in the mode, and let's see if we can get the fault to show in the ITM data console. To do that, if you click on run, it will go and run. It will enable the invalid state because we are on the usage fault 0x01. You can also view the usage fault by fault analyzer. So go to Windows, show view, and if you go to fault analyzer, you will see the message usage fault detected, attempted to switch to invalid state. So that's the usage fault. So you can actually see the details of what fault it is. So now it's on usage fault, and why it is saying it is attempting to switch to invalid state. That's why it's in that fault. And if you want to see that in the output trace, you need to click on trace and make sure that port 0 is enabled. Yes. And click on trace and run the project. Terminate and relaunch. Shutting down, it will relaunch. 1 sec. It's running. Still running with 70%, as you can see. 70, 80. Now waiting for debugger. Yes. Switch. Okay, we are in, and start the trace and go and hit the run button. See, now you can see the it's on usage fault, so you can, because we introduced that random address, so it is on the usage fault. To halt this, because there is no while loop, so you will see the usage fault. To stop that, you need to go and include while of one instruction in all the exceptions. So I'm going to copy that. I'm going to print that, into introduce that into everywhere. So now we just saw the usage fault. So let me go and change introduce an undefined instructions. So I'll change this, start with 2000101. I will terminate and relaunch the program. So we are slowly learning into undefined instructions. So this will show yeah, it's linked. Okay, still detecting. Okay, right click, debug as, and STM32 application. We'll wait for the debugger to change. it's changing to debug mode, so just please wait. 51%, 70%, 79, 90, the click switch. So now it's changed, and now it's in the configurable fault status register. So go here and hit run. As soon as you hit run, it comes to the usage fault. So if you want to see the fault analyzer, it will say usage fault detected, and what is its details? Attempt to execute an undefined instruction. So this is what we tried to do. We tried to execute an undefined instruction. So if you come here, we introduced 1001. So that's what it's saying. So it will be in the configurable status register, and you can see undefined instruction is enabled 0x1. So this is how you check and introduce error, and then to double check, come to the register and see that bit is enabled. That means that error has come through. So usage fault is 1. So that's good. So now let's go and see if we can do the execute never. So the other thing is, because we set all these 3 into the bus fault, so if I go and enable or make this as a comment, by default, if you run, because the usage fault is commented, and if I terminate and relaunch, what would that happen? Because it's not in any defined fault state, so therefore the compiler will assume and put into the undefined instruction into the hard fault that you will see now. So because I commented this, and now you'll see that in the once it goes to 100%, once it's in debug mode, I'll show the fault analyzer, it will be in hard fault. 93%. Yeah, we are in, and fault analyzer, no fault detected because we haven't run the project. So I'm running the project. See, it sends you as hard fault detected, and it puts that error into the hard fault, and the details of the hard fault is trying to get the forced by bus and memory management or usage fault, or it could be coming from the undefined instruction. So this is how the compiler knows and lists what type of project and what type of error code that is. And again, if you see the usage fault we commented, so it won't be enabled. So the bits are enabled with the bus fault and the mem fault. And if we come down here, it's still on the user in undefined instruction 0x1. So now let's go and check on the mem manage. So mem manage, how you can check, you have to go to the these registers come from your the registers come from here. So you need to take these addresses to check CR, CFSR, ED28, all this. So I'm going to take another register for execute instruction, which I'll show from this. We are trying to access to the execute never instruction, so I'll go on 4000 to see the execute never. Okay, I'll go, and here I'll change that 4000. Right, let's hit terminate and relaunch and see which error now that's putting us into. So likewise, you can also try in your downloaded IDE. If you go and give certain random address, and you can learn yourself about the different errors, how the compilation takes place, and how the compiler lists that and put in different address modes. So it's changing still into debug. So once it's in debug mode, then we will know what that error is. So just one moment. still loading. Debug, yeah, and then switch. Wait for the board to be connected. Yes, we are in the switch, and being in the configurable state, we haven't run the project, so nothing has enabled. So I'm going to go and hit run button. So as soon as you hit run button, the IACV violation, so that's a violation that happens because it's in the memory execute never address, so that violated the rules. So this bit is enabled, and if you can see, the CFSR configurable state is enabled, and the compiler classified that as the mem fault because it's execute never and it's in the mem fault, and all the 3 bits are enabled. So this shows the mem faults. Also you can check in window by going Windows, show view, and fault analyzer, and it shows memory manage fault detected, instruction access violation, IAC violation, instruction access, and that's a list. And if you want to see the same in the ITM data console, you need to click on start trace and then run again. Sorry, you need to terminate and relaunch to show in the data console. Just one sec. It's not far. The next one we'll learn about the mem manage again, just to see one more error, and we'll be moving on from learning today. Sorry, it's been a long experimentation, but I'm sure you are getting the hang of it. So when you introduce some random address, go into the register, you will see what address that is. The compiler lists that into and puts into a different fault, and you would be able to check by the registers itself. So now we are in the debug mode. Let's go here and click on start trace, and I'm going to run. See the exception now, it's in mem manage fault. There's start trace. So if you see the exception, so that's by default it's listed. Okay, so now let's go and change this to a different value. Let's see if I can get the mem manage fault by running this in as the address E123 and 123 and 0008. I'll just terminate and relaunch, and let's see what this fault is. This will show a mem manage fault because I just tried to access the peripheral bus, private peripheral bus, and execute never. So it's going to throw a different error this time. So I'll show. Okay, still in debug C mode. It's moving to debug. Switch, and if you come here, it's a configurable fault. Already the mem fault would be enabled there, and if you go and run, as soon as you run, it's configurable and the memory fault is on. If you go to fault analyzer, it will say the memory manage is, because we are on the execute detection, so that's why it's saying that error, and I hit and rerun, so that overwrites it, so no fault is detected. So let's try one more example. 20000 0001. Let's terminate and relaunch. Let's see what happens with this error. Waiting for the debug to change. So this is how you write your bus fault, and in long big programs this will be all declared already from the startup file, and you have to write and describe what fault you have to see. So 79, 89, switch. So it's going to go to manage usage fault, bit failed, enable the fault. Okay, so going, and it's on start trace, so run and go to fault analyzer, terminate and relaunch. Changing to debug mode. Then switch. And if you go to fault analyzer, just one step, just do a step instruction, step run. So now you can see the bus fault as detected. So as you can see, it's precise data access violation. So there is some sort of communication that went wrong in the bus analyzer, so you're getting the bus fault. So just wanted to show you the bus fault as well. So if you come here, the bus fault is enabled as 0x1. So we learned the bus fault, usage fault, and mem fault. So you can see the bus for valid state enabled 1. So the precise, that bit is 1. If you want to see the problem here, start the trace and go and run, and this will show bus fault in the console. So this is how you have to set your program and verify yourself, come to the registers, etc. So let's move from here. So we learned bus fault, we learned usage, we were in the exercise from current slide. So this is what we learned. And there are some fault status and addresses, like if you go and include this, and you will see different addresses. So try yourself and learn more from this. So what we learned today, so we learned what is a fault and the summary of fault handlers, and the 4 different faults of hard fault, manage fault, bus fault, and usage fault that you learned. And let's go into the mindset lesson for today. As you know, you got to prepare your mind as well when you develop your skill set, because that's vitally important. And I'm going to give you a spiral example today. I have listed 2 different spiral from the emotional guidance scale from Empowerment Guide. You have to always focus on the upward spiral, not on the downward spiral. So please don't fall for any of this anger, blame, discouragement, revenge, jealousy, insecurity, hatred, fear, grief. All this takes you down, and it will put you into the negative state. Whereas focus all your intentions and your attitude to all this joy, passion, enthusiasm, positive exception, being optimistic, being hopefulness, being contentment. All this will rise you to change you into a positive frame of mind. So your attitude will change, and that will put you into a better person, and this will also develop you over the days. Don't forget the involvement. So write down your top 10 goals, write top 10 ideas to achieve those goals, and please spend at least 30 minutes to do your workout and your exercise and go for a walk. And please spend another 15 minutes to meditate and pray, and spend another 10 minutes to actually visualizing that you actually achieved those goals, and then 10 minutes to plan for the rest of the daily activities. And for 2 hours of learning and taking notes, you'll get 2 points. And please do post all your achievements in the group, so the others will follow through with you and get motivated, and we are all going to help each other, so please do that. And that's some combo internship coming your way. I didn't want to cram too much information in one single module, so I separated into 3 modules. You already learned the beginner and we are on the intermediate state, so please do purchase all the 3 courses to give the whole Cortex M4 series. And there is more coming your way and you will be the first person to know. These are all under process, so all these programs, all these courses will be for you very shortly, and we'll let you know as soon as they are ready for you. And I thank you so much for every one of you for your time and your patience. Go and enjoy that lovely break from the screen. I'll see you in the next session. It is Arul Anbukarasu. I'm signing off on behalf of A2DG. Huru for now. I'll catch you in the next session. Until then, take care. Bye now. See you then.